All right, welcome to 7.4 and also welcome to Palos Verdes. I am out here enjoying my wife's birthday weekend, and her treat, her present was a nice stay out here by the Pacific. And so here, I'll show you the view from, this is our rooms right here. But really nice view here. I don't know if you can see the ocean way out there. Yeah, you can. Cool. Yeah, beautiful spot. Nice warm weather. Kind of dark for me right here though, isn't it? Maybe if I turn around, that's better. You can see the view as well. But that's what you're gonna be busy doing now. Okay, so extra credit trivia for a new location here will be Terranea, and it's spelled T-E-R-R-A, like Terra, like land, Nea, N-E-A. I don't know what Nea is. I'm gonna guess C is my guess, like it's something for C. Anyway, the extra credit opportunity is the property or the land that Terranea Resort now sits on. Used to be something else that was very near and dear to my heart. I used to love coming here. See if you can research and find out what was on this property in the past. Okay, let's go to 7.4 notes. Let me share those. And so we are going to start with this warm-up. So go ahead and just do this warm-up. So just some good solving of fairly short 1-2 step equations. And believe it or not, we'll actually be using this in this lesson. It's one of the steps. Okay, so go ahead and pause and do those 4. Okay, I'm back. And so obviously you subtracted 4 from both sides, got -13. You multiply both sides by 3/4, I hope, right? And remember, you always want to cancel first. So if I multiply both sides by 3/4, the 4 and the 8 would become a 1 and a -2. And then you multiply the -2 times 3 and you get -6. Okay, on the third one, you're going to add 2 to both sides, and then multiply both sides by 2. You get 54. And of course, you multiply both sides by 3. And what's great about these is you can check by plugging in, right? Let's check one. Let's plug the 54 in here. 1/2 times 54 is 27, minus 2, 25. Check, check. Okay, let's go ahead and solve these basic inequalities and then graph them on a number line, okay? Go ahead and do those. Okay, I'm back. So obviously we need to multiply both sides by -1 to get a positive z. Alert, 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 right? So we're gonna have to flip the inequality when we multiply or divide both sides by -1. And then what would this look like on a graph? Our key point would be 12. We'd have a closed circle, and z, what's gonna make this true is numbers that are smaller than 12. So that would be to the left on the number line. Okay, and then on this one, you added 8 to both sides. You got 44, and your graph should have looked like that. Filled in, arrow to the right of 44. All right. All right, learning target here is to know how to solve a polynomial equation using what we call the zero product property. Very easy to understand property. Okay, so what we're going to do here is you're going to work with me, and we have an equation that's considered to be in factored form when the product of the factors is equal to 0. So you can see the factored form right here, okay? Products mean 2 things multiplied equal to 0. We're going to match each factored form of the equation with its equivalent standard form and non-standard form, okay? So let's take a look at this. All right, so let's look at A. Well, think about it. How would I go from here to a standard form? You would FOIL, right? So go ahead and FOIL them out. So this would be x times x is x squared. This would be -3x, and -1x makes -4x, and then +3. Do we see x squared x squared minus 4x plus 3 anywhere? Yeah, down here it's C. Okay, so we know that is C, and then what would be the non-standard form for C? Any of these look like they may be another way of rewriting this, in other words, an equivalent form. Yeah, 5 does, right? If we subtracted 3 from both sides, we would have the same thing here. Okay, So this one was C5. All right, go ahead and try B, C, D, and E now yourself. You can get this. Pause the video. Okay, so hopefully you got D1, A3, B4, and obviously E2, okay? Again, with these, if you multiply out, we get x squared, negative 3x, positive 1 makes negative 2x, and then minus 3, that's right there with E, and E2, if we multiply this out, we get x squared minus 2x plus 1, and then if we subtracted the 4, we'd be back to this one, okay? So just some good practice moving from factored form to standard form. All right, so now I want you to work with me. We're going to substitute the numbers 1 through 6 in for x in each equation and determine whether the equation is true, okay? And then we're going to write a conjecture, which is kind of like an educated guess describing what you discovered. Okay, so let's do that. So let's plug in 1 here for these x's. If I plug a 1 in here and a 1 in here, I get 1 minus 1, which is 0, and 1 minus 2, which is negative 1. Well, I know 0 times anything is equal to 0, right? Okay, what about if I plug in 2? If I plug in 2, I get 2 minus 1, which is 1, and 2 minus 2, which is 0. Oh, well, a number times 0 is equal to 0. Okay, what if I plug in 3? Will that work? I get 3 minus 1, which is 2, and 3 minus 2, which is 1. So 2 times 1, does that equal 0? No. And you can probably see that if we plug 4, 5, and 6 in, it also won't work. So the only ones that work here were 1 and 2. Okay, try B right now. Okay, hopefully you saw that only 2 and 3 work. And you may start seeing a pattern here. The only way we're going to end up, did you get 3 and 4 for that one? What about for this one? 4 and 5, 5 and 6, 1 and 6. What are you noticing here? How would you write this? Think about it. Wouldn't it basically be like whatever makes either of the parentheses equal to 0 will make the left side equal to 0? Yeah. So it's the only integers that make the equation true, right, where the two sides are the same, are those that make either binomial equal to 0. Okay. So for example, like on D here, this binomial becomes 0 when we plug a 4 in. This binomial becomes 0 when we plug a 5 in, because 5 minus 5 is 0. Okay. This is kind of leading into the zero product property. Okay. These are kind of fun. Okay, the numbers 0 and 1 have special properties that are shared by no other numbers. Ooh, special. For each of the following, decide whether the property is true for 0, 1, both, or neither. Can you guys hear the sirens? I wonder what's going on. Anyway, so beautiful. I mean, look at the mountain there. See the? Can you guys see the observatory up on the hill? See the little round things? Pretty cool. All right. Anyway, all right. Let's go through these and see what we would put in here. A, when you add blank to a number n, you get n. What can you add to a number and still just get that same number? Yeah, 0. Good. Okay. If the product of two numbers is blank, then at least one of the numbers is 0. Now, we kind of just went through that, didn't we? Yeah. When the product's 0, then at least one of the numbers has to be 0. It's the only way you multiply and get 0 is if one of the factors is 0. Remember, factors are things that you multiply. Okay, C, the square of blank is equal to itself. What do you think? I think, does that work for 0? Yeah. Does it work for 1? Yeah. 0 and 1, so both of them. Great. D, when you multiply a number by n, or when you multiply a number n by blank, you get n. So n times what equals n? 1. Good. Okay. When you multiply a number by n, a number n by blank, you get 0. 0. Yeah. The opposite of blank is equal to itself. Well, the opposite of 1 is -1, so that's not it. It's 0, right? Or another way, sometimes people say 0 doesn't have an opposite, which is true also. Okay. And then for an extension, which of the above work for -1? Why don't you pause and try that? Okay, we're back. Did you get none of them? None of them work for -1. Ooh, little trick there. Okay, zero product property, here we go. If the product of two real numbers is 0, okay, in other words, if you multiply any two numbers together and you get 0, then at least one of the numbers is 0. Has to be. If you multiply any numbers, two numbers that are not 0, you're going to get either a positive or a negative, right? Okay. So in algebra, if a and b are real numbers, then a times b, ab, is equal to 0. Then what has to be true? Either a is 0 or b is equal to 0. Okay. And we're going to use that in order to solve quadratic equations in a minute. Okay. So using the zero product property, how are we going to use this? Okay. A polynomial is in factored form when it is written as a product of factors. We saw that back, remember, in kind of the exploration, right? So standard form would be x squared plus 2x. Factored form would be we pull out the common factor, x, and then we have x times a quantity, x plus 2. Notice if we multiply this back out, x times x gets me to x squared, x times positive 2 gets me to 2x. So they're equivalent, they just look different, okay? All right, x squared plus 5x minus 24. Remember, descending order by degree of the terms, right? This is a second degree term. This is a first degree term because it's x to the first. And this, remember, we could always think of as negative 24x to the 0 because x to the 0 is 1 and it doesn't really change anything. Descending order. Here's the factored form for it, okay? Notice if we multiply this out, x squared, 8x and negative 3x make 5x, and negative 3 times 8 makes negative 24. Okay. When one side of an equation is a polynomial in factored form and the other side is 0, use the zero product property to solve the polynomial equation. The solutions of a polynomial equation are called roots, okay? So if you have a polynomial equation, like if either of these have been set equal to 0 and you solve for it, the solutions are called roots. So if you see that word, you know what we're talking about. Okay, so let's solve each of these. These you can see are already factored for us, okay? So what do? We basically set each factor equal to 0. So we can set 2x equal to 0, x minus 4 equal to 0, and then we solve them. So what's going to x be in the first one? X would be 0, right? Or x equals, we'd add 4 to both sides and we get 4. You can see why we did this in the warm-up just to practice a little bit, okay? Notice if you plug in 0, 2 times 0 is 0, 0 minus 4 is negative 4, 0 times negative 4 equals 0. If I plug a 4 in, I get 2 times 4, which is 8, but then 4 minus 4 is 0, 8 times 0 equals 0. Okay, on this one, we can set x equal to 0, that's one of our factors, and we can set the quantity x minus 1 equal to 0. So obviously x is going to equal 0 or 1. Okay, you can try the rest of these. So why don't you pause the video and try these next 3. Okay, on this one, hopefully you set z minus 4 equal to 0, and also z minus 6 equal to 0, and you get 4 and 6. Again, if I plug a 4 in, this one becomes 0. Do I even need to plug it in here? No, because I know that I'm going to get some number, but I'm multiplying times 0, so who cares? I know it's going to be a solution. And same with 6, right? If I plug 6 in, this one becomes 0. I don't even care what that one is. I mean, I care, but no, not that much. Okay, hopefully for this one, you got 3 and 9. And here, hopefully you set 3t equal to 0 and t plus 2 equal to 0. And you got 0 and negative 2. Because if I plug a negative 2 in here, negative 2 plus 2 is 0. 3 times negative 2 is negative 6. Don't really care. Negative 6 times 0 is 0. Okay. Okay. Here's a probing question. Ooh. If the product of two factors is 0, will there always be two roots? Think about that. And the answer is, well, let's go through this and see. Okay, so here's one already factored for us. Set each one equal to 0, right? Here 2 steps to basically solve these, right? We need to subtract 7, divide by 2. And if I do that, I get negative 7 halves. And here I would add 7, divide by 2. So our two answers are negative 7 over 2, positive 7 over 2. Best way to write it, plus or minus 7 over 2. Okay, two solutions, right? Okay, so two roots. Let's go to this next one. What about x minus 1 quantity squared? Well, basically, wouldn't I just be setting x minus 1 equal to 0 and then doing it again if I wrote it all out? And wouldn't we get the same solution either way? We would get x equals 1. So how many roots are there? Just one, right? Okay, and we'll see this from time to time, okay? What about this one? Okay, here we have 3 factors, right? Do you think it works the same way? Do you think we set each of the 3 factors equal to 0? Yeah, of course. So, yeah, we set each one equal to 0 and then solve each one. Negative 1, 2, and 3. All right. Great. Okay, so go ahead and pause the video and solve each of these. All right, I'm back. So hopefully you set each factor equal to 0 and got those for your answers. And again, these look like they might be hard to check. They absolutely are not. Let's use the negative 5/3 one. If I plug in negative 5/3 and I multiply times 3, would the 3's cancel? And I'm just left with negative 5 plus 5, which is 0. And then I only have to plug it into the other one. And for the negative 8/5, if I plug it into the second one, the 5's cancel, I get negative 8 plus 8, which is 0. Don't even worry about plugging it into the other, okay? Here, any reason to write it twice? No, just do it once and you just get one solution in that case, one root, okay? And here, hopefully you got 3 of them, okay? If you want to take a break, if you feel like you want to stretch for a little bit, this would be a good time to do it as we're about to jump into the second half of the unit, or second half of the section now. Okay, so now we've talked about how to use the zero product. Now we're going to talk about factoring so that we can use it, okay? And let's read this because this kind of explains that, right? Okay, factoring polynomials using the GCF. What does GCF stand for? Oh, it says here, greatest common factor. Okay, good, yeah, you guys do that. All right, to solve a polynomial equation using the zero product property, you may need to factor the polynomial, right? Or write it as a product of other polynomials. We'll talk about that in a second. Look for the greatest common factor, GCF, of the terms of the polynomial. This is a monomial, one term, that divides evenly into each term, okay? In other words, what they have in common. So here's an example. Factor out the greatest common monomial factor from 4x to the 4th plus 24x to the 3rd. Okay, so look at your coefficients first. And what's the GCF of 4 and 24? What's their greatest common factor? Okay, yeah, 4, right? Because 4 goes into 4 once, 4 goes into 24. Remember, the GCF can never be bigger than the smallest factor that you're comparing, right? We couldn't have 6, right? 6 can't be a factor. It's a factor of 24, but it can't be a 4 because it's bigger than it. Okay. All right, now let's look at the other terms, other parts that they have in common, the x's, right? What's the greatest common factor of x to the 4th and x to the 3rd? Yeah, it's x to the 3rd, right? They both have an x to the 3rd in them, right? X to the 3rd times 1 would get me to x to the 3rd. X to the 3rd times x to the 1st would get me x to the 4th. Okay. So the GCF, is we're basically putting these together, is 4x cubed. Okay. Now, we're going to undistribute, right? So I'm going to basically pull a 4x cubed out of each of these and write what's left. So I would basically say, okay, 4x cubed times what would get me to 4x to the 4th? X to the 1st, right? So I'd write an x. And then 4x cubed times what would get me to 24x cubed? Well, I don't have to multiply by any x's, but I do need to multiply by the 4 by a 6. So it would look like that, okay? And then you can see if this happened to be an equation and it was set equal to 0, then, whoa, I have a B on my keyboard. Lovely. Can you hear it? It left. Thank goodness. That would not have been great to get stung. It would have been interesting, I guess, for the video, but not for me. It would be an overall good thing for me. Anyway, if this was set equal to 0, we could then set 4x cubed equal to 0 and x plus 6 equal to 0 and solve those. Okay, but let's just practice taking out the GCF of 8y squared minus 24y. Okay, look at the coefficients first. What's their greatest common factor? Good, 8, nice. And what about from y squared and y? What do they have in common? Hopefully you just said just a y to the first power. So 8y, okay. So what would our fully factored form be if I pulled an 8y out? Think about 8y times what would get me back to 8y squared, right? Just a y. And 8y times what would get me to negative 24y? What would I need to multiply by? Negative 3. Okay. Okay. Awesome. So now we're going to use the GCF, pull that out to factor it, our equation, and then we're going to use the zero product property. So we're putting the two things we just learned basically together. Okay, so, and you might be saying, well, why can't I just, subtract 8x? Well, then you'd have an x on both sides. How can you solve for x if x is on both sides? Doesn't make any sense. Okay, so let's factor out the GCF. Looks like the coefficients have a GCF of 2, and they both have at least an x to the first. So what, 2x times what would get me back to 2x squared? Yeah, x, and then obviously plus 4. Okay. Okay, now we're going to use the zero product property. So you set each factor equal to 0. So 2x equal to 0, x plus 4 equal to 0, and then solve those. Okay, negative 4 and 0. And then obviously go back and check it. Negative 4 quantity squared is 16, times 2 is 32. 8 times negative 4 is negative 32. 32 and negative 32 makes 0. And obviously you can see here, if I plug 0 in, this term becomes 0, this term becomes 0, 0 plus 0 equals 0. Okay, look at the right side. Ooh, what are we going to do here? Looks like we probably need to move, remember we just said we can't have variables on both sides if we're solving for it. So let's move the 15n over. And now let's take out the GCF. What would it be? Look at the coefficients first, then look at the variables. Okay, so hopefully you got 3n, okay? And then 3n times what would get me to 6n squared? Well, 3 would have to be multiplied by 2, n times another n to get to n squared. And then 3n times what gets me to negative 15n, multiplied by negative 5. Zero product property, and then solve them. So we get what? 0 and 5 halves, okay? All right, and like I said, pretty easy to check these. 0 is simple to check, right? And a little more complicated with the 5 halves, but 5 halves squared is 25 over 4, right? We'd square the numerator, square the denominator. So 25 over 4, and then with the 6, right, we could reduce the 4 and the 6 to 2 and 3. So we would have 3 times 25 is 75 halves, so 75 over 2. And look what happens when we plug in a 5 over 2 on the right side. 15 times 5 over 2, can't cancel anything. 15 times 5 is 75. 75 over 2 equals 75 over 2. It checks. Okay, so go ahead and pause the video and try these 3. Okay, we're back. Cover these. So hopefully you factored out the A, set each of those to equal to 0, and you got negative 5 and 0. This one, GCF is 3s. And then we have that times s minus 3. Again, 3s times s gets me to 3s squared. 3s times negative 3 gets me to negative 9s. Set each factor equal to 0. Solve. And then you could always plug in and check, which you always should do. Okay, on this one, can't have x's on both sides like that. So we're going to subtract 2x, pull out the GCF of 2x. We have 2x minus 1 left. This 2x times 2x makes 4x squared. 2x times negative 1 makes negative 2x. Set each factor equal to 0. And there's your answers. Okay. 0 is easy to check, right? Let's try the 1/2. 2 times 1/2 is 1. Okay. So on the right side, I get 1. 1/2 squared is 1/4 times 4 is, ooh, squirrel just went by. Whoa, squirrel. 4 times 1/4 is 1. 1 equals 1. squirrel. Show him to you if I can see him. I think he went behind this big, I don't know what you call this tree. It's not really a palm tree. I don't know what it is. Tropical tree. Looks like I'm in Hawaii. All right. Wish I was in Hawaii. Okay. All right. You can model the arch of a fireplace using the equation y equals -1/9 times squaring x plus 18, x minus 18, where x and y are measured in inches. Okay, so we're doing this in inches. The x-axis represents the floor. Okay, so here's our x-axis. You can see this arch. Okay, find the width of the arch at floor level. Well, what would the y-coordinate be at floor level? Yeah, 0. So in other words, we're talking about the x-axis, right? So we want to know what would make x, what the x's would be when y is at floor level. So floor level, y would be set equal to, good, 0, yeah. Now, notice the right side of the equation. Is that fully factored? Yeah, totally is, right? So we need to do what? Use the zero product property. Set each factor equal to 0, okay? Or before even doing that, what I could do is multiply both sides by -9. And if I multiply -1/9 times -9, those cancel out, right? So they make 1. So I would just have x plus 18, x minus 18. And 0 times -9 would still stay 0, okay? Another way of thinking this is we also could set -1/9 equal to 0. But does that make any sense? Do those equal? No. So you basically would just cancel that. Okay, then we're going to use the zero product property. So x equals -18 or 18. So we know that this point right here where it intersects is -18, 0. This one is 18, 0, right? So what would that distance be between those two? Think about it. And hopefully you said 36. So what's the answer to the word problem? 36 inches, okay? So what's interesting is that if we can graph something like this and figure out what our x-intercepts are, okay? In this case, we have 2 because it's what we call a parabola. We can find the distance between them, answer the question. Okay. All right, so now we're gonna do the same thing, but it's a mine shaft instead of a, what was this, a fireplace, right? It's a mine shaft, okay? We have our equation. This time it's in feet, and the x-axis represents the ground, okay? Well, what's the y-coordinate if it's a point on the x-axis? Yeah, same thing, 0, right? Find the width of the entrance at ground level. So we can set, that's the original equation. We can set y equal to 0. Could set each of the 3 factors equal to 0 or multiply both sides by -2. Doesn't really matter either way. I multiply both sides by -2. Zero product property. Set each factor equal to 0. X equals -4 and 4. What's the distance between -4 and 4 on the x-axis? 8. So our answer is 8 feet. Yes. All right, exit ticket. Write a polynomial equation that has -6 and 4 as solutions. Okay, so basically what we're saying is we would need to have this set up so that we would have solutions of -6 and 4. Well, what would make a binomial have a solution of 4? Well, basically, wouldn't it be something that was like where we could have x minus 4? So, right? Well, that's the final answer, but notice why that works. Because I can factor that to x plus 6, x minus 4. So probably what you would do is, let me get rid of this, get rid of that. But you probably would want to come up with these first, right? The x plus 6, x minus 4 equals 0, right? Because that's the easiest place where you could find, figure out, okay, I know if I plug a -6 in there, that's going to be a solution. If I know I pull a 4 in there. And then what did we do to go from here to here? We FOILed, right? X times x is x squared. X times -4 is -4x. And then combine that with the inside. 6 times x is positive 6x. So positive 6x and -4x makes positive 2x. And 6 times -4 is -24. Okay? So that would be one way of doing that. All right, lots of good stuff. Zero product property, GCFs, putting it all together. We're solving. This is the first of 4 methods you'll learn. The other 3 methods will come in chapter 9. But the first of 4 methods for solving quadratic equations. So congrats, it's awesome. It's good stuff. All right, I will see you later. See you back in Brentwood. Goodbye from Terranea. Remember the extra credit.